Okay, so hopefully I've turned everything on that I'm supposed to do. So transformation is just a fancy way to say change. And so we're going to talk about all the different ways that we can change, but first we're going to have some vocabulary, some understanding of what symbols mean. So a transformation is an operation that maps an original figure called the pre-image onto a new figure called the image. Now this is where it's a little, oops, helps if I can spell no, I had it right. This is where it's tricky. Like you would think that the first one would be the image and then the second would be like a post image or a second image or something like that. But whatever you start with is called the pre-image, and what you end up with is the image. That's what the translation is. So notice this next section. On this graph, let me see if I can zoom in a little bit. On this graph, look at the B. See that little mark next to the B? That's an apostrophe, and we read that as prime, B prime. That just means it's the second one, and notice that the image is all of the primes. So on the graph to the left, we have triangle ABC. So triangle ABC is the pre-image. That's where we start. And triangle A prime, B prime, C prime is the image where we end. Catch. You can keep that. All right. So a transformation can change a couple of things, 3 things actually, about any shape. It can change its position, its orientation, or its size. So when the notes are in the back, Ruby. When we transform something, I can either just slide it, that's called a translation. I can mirror it, that's a reflection, or I can dilate it, which changes its size. It makes it bigger or smaller. And we'll go through all of those in this section. Today, we're going to focus on translations. So, rigid motion. What does rigid mean? Like when you hear the word rigid, what do you think of? Rigid is unmoving, or I guess stiff. So when a transformation preserves the size and shape of a figure so I move it, but nothing changes. It doesn't go from a square to a rhombus, like I don't tweak it. It doesn't get bigger or smaller. Nothing changes except its position. So if I make Gage move from where he is up front, that's a rigid transformation. Nothing about him changed except his location. But if we pull out the shrink gun from, Despicable Me, that would be a dilation, which is not a rigid transformation because his size changes. So all corresponding, remember what that means, matching, all corresponding sides and angles of the pre-image, remember that's where we start, and the image where we end up are congruent. So if I move something, nothing changes. It doesn't get bigger or smaller. The angles don't change. I didn't break anything, just like that. So examples of rigid motions, the three transformations that we most often deal with are translations, reflections, and rotations. So transformation is the overarching, we're going to change and move something. And translations are how we do it, reflections are how we do it, rotations, and we'll also deal, I think, a little bit in dilations at the last. But today's lesson focuses on translations.
Miss Abby,
Uh-huh.
what's that word?
Which one?
Going between image and
This thing?
yeah.
That's an and, like this. It just means and. All right. So, let's talk about the first one, translations. Translations are to vertically and or, that means I can do both or just one, horizontally slide a figure. So like I'm just going to take it, like if I move Gage, we're going to move him horizontally to Jackson and then vertically up in front of me. We're just sliding him someplace. We're not rotating him. If I make him move up here and turn around, then that's a rotation. If somehow I can reflect him across a thing, he would be on his head somehow. So we're not doing those things. It's just a slide. We're just shifting places. Think about a chessboard. So coordinate notation, the way that we write this, because we always have to put numbers into everything. We start out with X and Y. So the original coordinates are X and Y. And that shifts to X plus H. So X plus the horizontal change. And then, actually that's not what I wanted. Go back. Y plus K. And we use K for the vertical. So we'll put a K above the vertical and an H above the horizontal. Oh, which it then says in the bottom. That's what I get for reading ahead. So H represents the horizontal shift. And most of the time we're going to get this from counting. And K represents the vertical shift. All right. So let's look at this first example. So we're going to identify the coordinates of the image. Which one is the image? Where we start or where we end? Come on. Where the image is where we start or where we end? Where we end. So first, I have to graph my pre-image. I have to graph the first thing. So Q is -6. 1, 2, 3, 4, 5, 6. -1. So here's Q. And then -3, 1. There's R. And S is 1, -5. And T is -2, -7. So that's my image. Notice there's no little marks next to it. Oh, sorry, this is my pre-image. Now, this tells me how I'm shifting it. So how am I shifting it horizontally? 5, which direction? Left or right? To the right. And then 7, up. So each coordinate, we're going to add 5 to the x and 7 to the y. So Q prime, what's -6 plus 5? -1. And -1 plus 7 is 6. So -1, 1, 2, 3, 4, 5, 6. Here is Q prime. That little mark that I put, hi Natalie, hi Ernesto. That little mark that I put tells me where that's my image. So then we're going to do R. So -3 plus 5 is 2. 1 plus 7, 8. So that's R prime. And don't forget to put the little primes next to the letters as we're doing it. So then we have S prime. 1 plus 5 is 6. -5 plus 7 is 2. So 6. 1, 2, 3, 4, 5, 6. Up 2. There's S prime. And then T prime. -2 plus 5 is 3. -7 plus 7 is 0. So that's T prime. And put S on the other side. Now, when you're doing this, you really should be using a straight edge. The easiest straight edge, I can give you all index cards. That works a lot better, but you want to make this as pretty as you can make a math drawing. Like straight lines, decent handwriting. Like you want it to be nice because it changes. If you're sloppy, then you're not going to have the right ideas. So down here where I was being, so Q prime is -1. Actually, we'll go back and do it like this. Q prime is -6 plus 5 and -1 plus 7, which is how we got -1, 6. S prime is 1 plus 5 and -5 plus 7, which is how we got 6, 2. T prime is -2 plus 5 and -7 plus 7, which is how we got 3, 0. And r prime is negative 3 plus 5 and 1 plus 7, which is how we got 2, 8. You don't need to write this down, but that's going to be how I know how you did it. That's going to be the way that I can tell. So this is the image. Shh. Hey, focus on this. All right. So now we're going to do a triangle. So the first thing that we do is draw the original triangle. So 2, negative 1, that's C. 7, negative 4, that's D. And E is 4, negative 6. Is that right? Yep. And that's E. So there's my original triangle. That's my pre-image. So now we're going to use this math to get to the next section. To get to the next coordinates. So starting with 2, negative 1. This time I'm going to subtract 3. So 2 minus 3 is what? 2 minus 3 is negative 1. And negative 1 plus 8 is 7. So C prime is negative 1 up 7. So there's C prime. If your diagrams don't have that mark right there that tells me that that's your image, it won't be correct. So then we do for E, 4 minus 3, that's 1, and negative 6 plus 8, that's 2. So 1, 2 over 1 up 2, that's E. And then D is 7 minus 3 and negative 4 plus 8, which is 4, 4. So over 4, up 4, that's D prime. That's it. It's not designed to be difficult, it's just designed to be precise. It's not that we're just moving something, we're moving it that far. And what does that look like on a graph? Sometimes they can overlap. If you look at the last two, which you'll have a chance to work on here in a minute, that 3 overlaps, whereas 4 does not. So go ahead and look at 4 for a second on the back. I'm not going to do those for you right now. I want you to do them by yourselves in a minute. But what does, look at number 4, and the slide or the translation, what am I doing to the X? I'm moving it to the left. What am I doing to the Y? Am I moving it? No. So it's not going up or down. I'm just literally sliding it across. Everything else has been 2 ways, right? We go up and left, down and right. But this one, I'm just shifting it over. So it's okay. That just means that when it says Y like that, there's no adding or subtracting. Whatever Y was, Y stays. Take a second and work on those 2 problems. I'll set a timer. I'll give you 5 minutes. Oh, wait a minute. What time are we out of here? Yeah, 5 minutes. Yeah.
Where is the key?
There's one right there unless somebody's using it. And then there's, you know what? Right here on the end of this thing is an outlet, and it's plugged in on the other side of that by Aurora.
Is this something new? What I hear?
No, go ahead. If it'll reach you, go ahead.
Oh, thank you.
Oh, they're back there on the thing. Trying to figure out what I'm doing.